Let us have another example of polynomial curve fitting. Find the polynomial function that fits the points -2, 3, -1, 5, 0, 1, 1, 4, and 2, 10. So, pause the video and try to apply the different steps in polynomial curve fitting. Alright, so first, we need to determine what polynomial function are we going to look into. So we have 1, 2, 3, 4, 5. Since we have 5 points and we need to have 5 minus 1 degree, then we're going to look into a polynomial of 4th degree, sometimes known as a quartet equation. So therefore, a quartet equation will have the form y is equal to, oops, it might not fit, so let's write it below that. Y is equal to a sub 1 x raised to 4 plus a sub 2 x cubed plus a sub 3 x squared plus a sub 4 x plus a sub 5. So, using this polynomial model, we can now plug in the values. First, we're going to have 3 would be equal to a sub 1 negative 2 raised to 4 plus a sub 2 negative 2 cube plus a sub 3 negative 2 squared plus a sub 4 times negative 2 plus a sub 5. Then, plugging in the next point, we'll have 5 is equal to a sub 1 times negative 1 raised to 4 plus a sub 2 times negative 1 cube plus a sub 3 times negative 1 squared plus a sub 4 times negative 1 plus a sub 5. Plugging in the other values as well, we'll have the following equations. So we'll have 1 is equal to a sub 1 times 0 to the 4th plus a sub 2 times 0 cubed plus a sub 3 0 squared plus a sub 4 times 0 plus a sub 5. Then we're also going to have 4 is equal to a sub 1 times 1 raised to the 4th, a sub 2 1 cubed plus a sub 3 1 squared plus a sub 4 times 1 plus a sub 5. Finally, we're going to have 10 is equal to a sub 1, a sub 1 times 2 to the 4th, a sub 2 times 2 cubed, a sub 3 times 2 squared, a sub 4 times 2 plus a sub 5. By now, probably you have noticed, let's just pull that up, you have noticed this specific equation. The third equation has all the values here at 0. So, since we know any number multiplied to itself is 0, including itself, a raised to 4 is 0. And a times 1 times 0 will be 0. So that would mean that we already have one equation worked out for us, which is actually, if we place it in equation form, a sub 5 will be equal to 1. Now that we've adjusted it a little bit, I'm now going to get directly the values here into an augmented matrix. It will be a little bit difficult for some to follow, but what I'm going to do is just get the coefficients. What will be, in a way, efficient instead of me writing the system and then writing it again as a matrix. I will just need to get these numbers as the coefficients, and then of course these numbers as the constants. So, writing this in a matrix, we're going to have the following. So, we have 1, 2, 3, 4, 5 rows. 1, 2, 3, 4, 5 rows. Let's have that. 1, 2, 3, 4. Oops, sorry. 5 rows. There you go. Let's just fix that. 5 rows. 1, 2, 3, 4, 5. There we go. And we're going to get already these coefficients. This would be 16, then negative 8, there you go, negative 8, 4, negative 2, 1, and then 3. So we will do the same for the others, so we can easily solve this problem. So I'm going to have here 1, negative 1, 1, negative 1, 1, and then 5. Our third equation, which we have already established, everything is 0 except the last one, and that would be equal to 1. The fourth equation is all 1, so that would be easy as well, except of course for the last one, which would be 4. And finally, we're just going to have here 16, 8, 4, 2, 1, and 10. So now that we have our augmented matrix, we can now use Gaussian or Gauss-Jordan elimination to solve this system. And again, I'll be using Gauss-Jordan elimination to get the reduced row echelon form of our matrix. However, the process of doing the Gauss-Jordan elimination will be left to the viewers. Hence, the reduced row echelon form of this matrix would be as follows. There you go. So the reduced row echelon form, after solving it, will we have 1, 0, 0, 0, 0, then negative 17 over 24. The next one will be 0, 1, 0, 0, 0, 3 fourths. Then the next one would be here, it's 101 over 24. The other one would be negative 5 fourths at the end. And the last one, as we already know, is just simply 1. Therefore, from the reduced row echelon form, we can now see that the values of our constants are as follows. We have a sub 1 is equal to negative 17 over 24. A sub 2 is 3 fourths. A sub 3 is, A sub 3, there you go. Let's just fix that notation. A sub 3 is 101 over 24. A sub 4 is negative 5 fourths. And A sub 5 equals 1. Therefore, the polynomial function that we're looking for of the fourth degree would be y is equal to negative 17 over 24 x to the fourth plus 3 fourths x cubed plus 101 over 24 x squared minus 5 fourths x plus 1. And that is another example of polynomial curve fitting.